In this lesson, you will learn how to find the sums of finite arithmetic and finite geometric series. If you're given an arithmetic series, such as 2 plus 4 plus 6 all the way to 100, remember we can pair up the term with the term number, and so 2 would be your first term, 4 is your second term, 6 is your third term, and etc. And then if you keep this going, 100 would be the 50th term. Now when you're adding together a series, there is a quick way to represent the number of terms that we're hoping to add. So if you're trying to add the first 50 terms, such as in this case, you would represent that with a capital S for sum, and then a 50, meaning you're adding the first 50 terms. If you had, say, S and then a 2 underneath, this would equal the sum of the first 2 terms. So 2 plus 4, which would be 6. S with a 3 underneath would be adding the first 3 terms, so 2 plus 4 plus 6, which would give you 12. So S50 would be the sum of the first 50 terms. Now, if you're given the same series, and we're trying to add the first 50 terms together, so this entire series as we see it. Now, yes, we could add the 2 plus the 4 plus the 6 and keep going all the way to 100, but that's going to take a very long time. So the objective is to figure out, is there a quick way that we can add these together? And yes, there is a quicker way, where if we add the first term and the last term, notice we'd get 102. And then if you work to the next two numbers, so the second term and second to last term, the 4 and the 98, and you add those together, you would also get 102. If you add the 6 and the 96 together, we would also get 102. And you keep going all the way to the center, and each time you're going to be adding those together, you're going to get 102. So the question is, how many times do we have to add 102 together? How many groups can I make of 102? Well, we said there's 50 terms here. So because there are 50 terms total, and we're taking groups of 2, then there are 25 groups that we are going to take. So 25 groups of 102 would be 25 times 102. So my solution would be 2,550. So that is a process that we're going to use to add together an arithmetic series. And in general, what we just did was we took the first term, we'll call that T1, added that with the last term, Tn. So we take T1 plus Tn, and that's going to give me this number here. And then the question is, how many of these are we going to take? Well, we had 50 terms, and we had to divide by 2 to figure out the number of groups that we had. So if we take the number of terms, which is n for number of terms, and divide it by 2, that's how many groups we have of the first term plus the last term. So my formula that we can use is S sub n, meaning the sum of whatever number of terms that we'd like, equals the first term plus the last term times n over 2. Or another way we can write this would be putting everything over 2, where you have n times T1 plus Tn over 2. So using this equation, I can solve any arithmetic series. And Sn is the sum of the terms, T1 is term 1, Tn is the last term, and n is the number of terms. So here's another example where you have this series, 3 plus 6 plus 9, all the way to 90. So you want to use the formula, S sub n equals n times T1 plus Tn over 2. So first off, we need to know n. N is the number of terms that we have. Well, the number of terms we have, we can find by counting. So we have 1, 2, 3, 4, and we keep going all the way to the number 90. Well, instead of counting all the way to 90, what we can do is figure out the pattern this way, between the 1 and the 3, between 2 and the 6, between 3 and the 9, and etc. So notice we take 1, the term number, multiply it by 3, we're going to get 3. 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12. So this number over here must be 30, because 30 times 3 would give you 90. So n would be 30. That's the number of terms that we have. T1 is term 1, which is going to be 3. And then Tn is the last term. So the last term is 90. So we plug everything in. So we have s sub 30, so the sum of the first 30 terms, equals 30 times 3 plus 90 over 2. Then we solve this. We have 3 plus 90 is 93. So 30 times 93 over 2 would give you 1,395. Here's another example with a little more difficulty. Here we are trying to find the sum of the series given 2 plus 5 plus 8 plus 11 all the way to 47. Now we know we're going to use the formula, and to do that we need to figure out the number of terms. So we can pair up each number with the term number. So we see here we have term 1, term 2, term 3, term 4, etc. So here's the formula, and we need to figure out what is n, what is your term number, how many terms do we have. Well, to find that we need to figure out the pattern vertically. So 1, term 2, term 3, what is the pattern between these numbers, between 1 and 2, 2 and 5, 3 and 8, 4 and 11, etc. Well, here, this is kind of the same concept that we use for the summation notation, where notice for a second horizontally, the pattern to get from 2 to 5 is you're adding 3. So you're adding 3 each time. So a technique I can use to figure out the pattern vertically is taking that 3, multiply by n, and then add or subtract something as needed. So if I take 3 times the term number, so looking at the first one, we have 3 times 1, we're going to get 3, but I need to subtract 1 to get to 2. So 3 times 1 minus 1 would give me 2. Looking at the next term, 3 times 2 minus 1 would give me 5. 3 times 3 minus 1 gives me 8, and etc. So the pattern vertically is 3n minus 1. So 3 times the term number over here is going to give me 47. So 3n minus 1 is going to be 47. I can solve this by adding 1. I get 3n equals 48. And then divide both sides by 3. We get n equals 48 over 3, which is 16. So we have 16 terms. So n is 16. And then t1 is the first term. t1 is going to be 2. And then tn is the last term, which is 47. Plug everything in. I now have 16 times 2 plus 47 over 2. So I get 16 times 49 over 2, which gives me 392. Now let's increase the difficulty one more time, where here I'm told to find the sum of the first 40 terms given this sequence. And actually it would be a series because we're adding everything together. And so here's the formula, and we know n is the number of terms. So n is going to be 40 because we're finding the sum of the first 40 terms. And then t1 is term 1, which is going to be the 2, that's your first term. But the tn, the last term, we don't know what that is yet. So what I need to do is use the formula found in the previous lesson, where I find the nth term, where I have tn equals t1 plus n minus 1 times d. So here I plug everything in. t1 is term 1, which is 2. N is the number of the term we're trying to find, which is 40. And then d is your common difference, which in this case we're adding 3 every time. So d would be 3. So what I have is t40 equals 2 plus 40 minus 1 over 3. 40 minus 1 is 39. So 39 times 3 plus 2 would give me 119. So tn, the last term, would be 119, which now I can plug into this formula, where now I have 40 times 2 plus 119 over 2. 2 plus 119 is 121. 121 times 40 over 2 would give me a solution of 2,420. Now the next example is not really any more difficult, but it's a little different. Where here we are now given the summation notation, and you're told to find the sum of this series. Well, the first thing you want to do is figure out what numbers do we have in this series. What series does this represent? So to find that, I plug in the numbers 1 all the way to 20 in for k. So I plug a 1 in for k, so I have 5 times 1 plus 2. Plug a 2 in, so I have 5 times 2 plus 2. Plug a 3 in, I have 5 times 3 plus 2. Keep going until I put a 20 in, the last number up here, to get 5 times 20 plus 2. So that would give me 5 plus 2 is 7, 10 plus 2 is 12, I get 17, and then the last one would be 102. So notice this is a arithmetic series because each time I'm adding 5 to get to the next number. So now to find the sum, I can use the formula, plug in everything I know. N is the number of terms that we have, and we know we're going from 1 to 20 for the terms, so we have 20 terms total. So N would be 20. T1 is the first term, which is going to be the 7. And then Tn is the last term, which is 102. Plug everything in. I have 20 times 7 plus 102 over 2. And I solve that. I'm going to get 1090. Now we're going to switch gears and talk about a geometric series. Now the formula for a geometric series is not as intuitive as it is for the arithmetic series. So I'm going to walk you through where the formula comes from. And if you don't understand exactly where it comes from, that's not a huge deal, as long as you know how to use the formula at the end. So where the formula comes from is the fact that we know to find the sum of a geometric series, we're adding up together the terms of the series. So let me explain what we have here. S sub n is going to be the sum of the series. We take the first term plus the second term plus the third term all the way to the last term. And to get from term to term, this is term 1, this is term 2, etc. To get from term 1 to term 2 with a geometric series, we're multiplying by r, the common ratio. So to get from term 2 to term 3, I multiply by another r, so r squared. To get to the next term, multiply by another r. Keep going until the end, and I'm going to multiply by r n minus 1 times. I'm trying to find the sum of the first n number of terms. We start with term 1, and this is term n. But notice the number of times you multiply by r is 1 less than the number of terms we're trying to find. Right? Term 2 only has 1 r that you multiply by. Term 3 has 2 r's. And if you keep this going, term n would have n minus 1 r's. So that is where this comes from. And then what we do is we multiply both sides of the equation by the common ratio. So when I multiply both sides of the equation by the common ratio, on the left side I have r, the common ratio, times s sub n. On the right side, when I take t1, this first term, times r, I get t1 times r. Multiply the second term times r, I now have t1 times r squared, which is right here. Keep this going until the last term, and t1 times r to the n minus 1 power. Multiply that by r. I add the exponents. Now I have r to the n power. So from here I have two equations that are equal. And what I can do from here is I can subtract these two equations from each other. So when I do that on the left side, s sub n minus r s sub n. And then over here we have t1 minus, there's nothing to subtract it with, so we just have t1. But then t1 times r, subtract that from t1 times r, that will cancel. And then t1 r squared minus t1 r squared will cancel. And all of these will cancel all the way until the end, except for right here, there's an assumed 0. So 0 minus t1 times r to the n power would give you a negative t1 r to the n power. So because all of the zeros here, I'm left with now s sub n minus r s sub n equals t1 minus t1 times r to the n power. And then from here, my objective is to have a formula that is solved for s sub n. So what I can do, looking at the first two terms on the left side, notice they both have an s sub n in common. So what I can do is I can factor an s sub n out, and in parentheses I'm left with 1 minus r. Because s sub n times 1 would give me back out the s sub n, and s sub n minus r, or times a negative r, would give you a negative r s sub n back out. So from here, to solve for s sub n, I can divide both sides by 1 minus r. So when I do that, I now have s sub n on the left side by itself, and on the right side I have t1 times 1 minus r to the n power over 1 minus r. And this is the formula that we can use to find the sum of a geometric series. And once again, if you do not understand all of that, it's not a big deal, but it's helpful to know that these formulas do come from somewhere. And from here we're going to work with how do you use this formula to solve for the sum of a geometric series. So here is example 1. We have a geometric series where each time I'm multiplying by 2 to get to the next number. And the formula is s sub n equals t1 times 1 minus r to the n power over 1 minus r. So t1 is going to be term 1, which is the 3, and then r is the common ratio, which was 2, and then the n is the number of terms, which is going to be 20. We have 20 terms we're trying to find the sum of. So plug all of that in. We have 3 times 1 minus 2 to the 20th power over 1 minus 2. 2 to the 20th power would be this number. We subtract, we get a negative 1,048,575. Multiply by 3, divide by negative 1, and we get 3,145,725. Now looking at the same series, except going the other direction where the numbers keep getting smaller, our objective is to find the sum of the first 10 terms of this sequence. While using the formula, I plug in everything I know, where t1 is term 1, so t1 is going to be 24. R is the common ratio, and this one, be careful, because yes, you're dividing by 2, but your common ratio by definition is what you're multiplying by to get to the next term. So multiplying by 1 over 2. So my common ratio is 1/2. And n is the number of terms, so we're trying to find the sum of the first 10 terms, so n would be 10. So plug those numbers in. We have 24 times 1 minus 1/2 to the 10th power over 1 minus 1/2. And you can use your calculator for this. 1/2 to the 10th power subtracted from 1 would give you 0.9990234. Multiply by 24 and divide by 0.5, and we're going to get a solution of 48. And that concludes our lesson for today. We will see you next time.